All right, there we go. The floor is yours. I'm going to mute now.
Right. So this is kind of like an update to the project I've been working on for like the last almost 2 years, I think, on and off, something like that. So it's called Geminus, and kind of the tagline here is it's a healthy office habits assistant. And so I'm going to kind of start with trying to first describe like what Geminus is, because I know some of you know something about it, others might be not so much. But basically, the product vision is to make an office health assistant. And the way that this works is it basically is using a camera to monitor your own work habits while you're at your desk. And so habits being things like how do you sit, how much do you stand up, how often do you take breaks? And the idea here is to kind of be able to create two types of value for the user. The first one is like this immediate call to action. Like, for example, you're hunching right now, please straighten your back. Or you've been sitting for the last 60 minutes, please stand up, go around or something. Or you've been working for 2 hours, meaning you've been present at your desk for 2 hours, please take a break for like a few minutes. And these are like, of course, configurable in terms of how much do you want to stand, how much do you want to take breaks for, and all of that. So these are like immediate calls to actions, but also there are like more kind of long-term things, because the idea is that the camera can monitor your habits for days and hours. So I have, for example, already collected, almost a year worth of data about my own habits using this. And so it can also give you long-term patterns, such as you've been sitting for 90% of the time during the last 3 months while at your desk, or your average posture has worsened over the last 30 days, things like that, that kind of give you like a reflection on your long-term habits. And maybe you want to reconsider changing your table or your chair or something else if you think that your environment isn't supporting the best habits that you want to have. So that's kind of the high level overview of what the product is about. So I'm going to, of course, now show you like in details of what it is, but that's kind of the high level pitch. And so because some of you, again, already know something around this project, I'll kind of quickly show you the timeline of the project, so just to make sure everybody on the same page about what is new in this presentation, what is not. So the project kind of started in 2020, October. There was the previous time I talked about this project on this meetup was back then. And then back then I basically demoed very basic features, such as image analysis for presence, for sitting and for standing. So those was kind of like a first attempt to solve this kind of like tracking with a camera problem. So I had that algorithm, and then I'm like, okay, so how do I package that into like a very convenient way for the users to interact with? And so I spent basically all of 2021 building an iOS app and testing different UX, testing different flows, trying to understand how to make this experience such that a child or a person who's very busy can quickly understand how to use the app and make the best out of it. And so I had this private beta kind of going on throughout 2021, collected some feedback from users here and there, kind of friends and relatives and stuff like that. And so with that in mind, I realized that I wanted to add more analysis into the app, and in particular, the posture was the one that I ended up doing. And so today, what I'm kind of demoing is the algorithm itself for posture analysis. And the idea is that in the next few months, I'm going to kind of add this posture analysis into the iOS app, and then the iOS app will be publicly available with this functionality as well. So today is more of just like a proof of concept demo rather than the final product, but hopefully it will get you excited anyway. So before I get into the posture, the history of this, and this is what the app is already doing. This thing I demoed, a year ago, was basically this detection of whether the person is standing or sitting, or whether they are present at their desk. This was essentially kind of the basic features I had from the very beginning, and these were useful. I use them all the time because I use a standing desk all the time, so they were super useful for me. I've been using this app for more than a year now. Super helpful to my particular world, at least. And so the idea is that there's a camera that does some analysis. And so what kind of camera can be used? So my kind of first original hardware option was this Raspberry Pi camera that you can kind of buy from online. It's a kind of like a hobby camera setup and starting. So there's a camera here. There's also, let me actually turn on the laser pointer. So there's the camera itself here. Here's the lens. There is a computer attached to it which can do computations using a Linux. And I also added a tripod for convenience. So this is kind of also what I'm using right now. I will be demoing today is using this approach. It's very convenient. It's a little bit not as straightforward to use as an iPhone, but it's very, very good for kind of like long-term tracking. But when I did this option originally, I was like, okay, maybe everybody can buy a Raspberry Pi and then install my software and use this. And the thing is that like this whole setup here costs maybe like $200 retail. And so that's kind of like a very high price for just to try something. And so that's why at some point the hardware option number 2 came in, and I made this an iOS app that can basically do the same thing as the Raspberry Pi option, but you can use your iPhone instead of the Raspberry Pi or iPad actually as well. So here's kind of the actual photo from me using this iPhone with this Geminus app and actually working on my computer. So that's kind of the second option. And again, my intention is to continue supporting both of these options. I think the iPhone is better for first-time users, but the Raspberry Pi option or some other custom camera option is better for long-term usage. Because you don't have to, because here you have to use your iPhone, you have to remember to turn on the app, put the iPhone on the tripod. With the Raspberry Pi, it can be there 24/7 for years at a time, and it's a lot more convenient.
Can I ask a question about the lenses, like between iPhone or this Raspberry Pi? How sensitive is it to like different lens curvatures and that sort of thing?
Yeah, that's a good question. I have a slide about the lenses. Well, just maybe a few words about the lenses, but lenses are a pretty important question for sure. Here I'm using a wide angle lens. I have a few more lenses that I'm using. They have pros and cons with respect to the experience they give you and how they affect the analysis. So and obviously the iPhone, at least some of the iPhones also have multiple lenses to choose from. Yeah, I'm not going to. So there's a trade-off there that I'll describe quickly later. But yeah, lenses do affect this quite a bit for sure.
I have one question. How did you take this picture?
I mean, I use like a DSLR camera too.
No, I know you have a million cameras, but it's just it's like very meta. You know, it's like Anyway,
I like it's like a blurred background, but you can see very clearly here on the iPhone. Anyway, so I had this app. It's like in private beta last year. I gave it to a bunch of friends and whoever wanted to try this. And so I was like collecting feedback about all kinds of things. And like, so one of the features of the app, of course, and also the Raspberry Pi as well, that there is a dashboard for all the analytics. So this is a screenshot from the app. In the app, of course, since I only have like the standing and presence or sitting detection, like all the metrics here and statistics are around that. But that's kind of the idea, is that besides alerts in real time, you also get gathering of information in the long term. So that's kind of and I think it's very important, not just to have alerts, but also to understand the long-term patterns to understand how your habit's doing in the long term. And then, so we had this app and I was asking about feedback, and like the number one feedback pretty much from everybody I asked was like, what about posture? Can you do like fine-grained posture analysis? So this Leonard here is a comment on YouTube under the video is a demo I published a few months ago. And so he summarized it pretty well. If you can add spine curve while sitting, you can take my money. Well, Leonard, I have the spine curve while sitting, so prepare your wallet.
Oh, let's go.
Yeah, it's pretty cool. I think everybody wanted posture, so it was pretty clear that posture has to be the next feature to pretty much everybody who thought about this product for a while. So let's talk about posture in particular. And the first thing I wanted to talk about is like the competition. Like, what are the alternatives to this whole problem? And so I see three categories of competitors. The first one is a variable sensor category. The obvious big name in this category is Upright. Maybe you've seen their ads or even tried this thing before. It's a variable battery-powered, Bluetooth-enabled sensor that kind of you use a necklace to put it on your back, and it measures the angle of the device versus the horizon. And that's how it knows whether your back is angled correctly, but it only does it in one single point. It's where the device itself is. So that's limited, but also kind of nice because it's also pretty straightforward to use it. And the idea is that it has Bluetooth. It sends data to your iPhone, and then your iPhone can alert you that you're not sitting straight or something like that. It's a good solution, but it's limited because it has very little information. It literally only knows one angle and one point of your spine. That's not a lot of data, to be honest. And I'll show you today in my demo that I'm getting a lot more data than this out of the camera. So it's definitely gets a lot more insights. The other category of competition is the variable correctors, or whatever else you call them, is like these things that you wear that are actually physically forcing your body into the right posture. And this is like a very old solution. Obviously, people have been doing this for hundreds of years. There is a lot of brands doing this. And I think this one is a real competitor in the sense that it forces you to be better, to do better in terms of posture, at least. And of course, both upright, it can notify you that your posture is bad. Like my product can also notify you that your posture is bad, but we cannot force you to be better with your posture. This thing kind of can, so that's a very serious competition, to be honest. And the third category is like this kind of abstract category of somebody telling you that your posture is garbage and you should sit up. And it could be your mom, your friend, your coworker, your roommate, whoever is looking at you while you're at your desk can tell you that. But here's the thing: they can tell you that maybe once a day, maybe a few times a day. Like they can't tell you, they can't watch you 24/7, like, or every minute that you're at your desk and like every minute remind you to sit up. That basically doesn't work. Or maybe you live by yourself, or you don't want to bother your coworkers and they don't care about you either, so I'm not going to tell you anything. So I think this category is a free category. Like people will give you an advice for free, but they will not be doing it 24/7, which is something that my product can.
I have a comment and a question. So
Yeah.
my first comment is, if anything, the fact that there's competition validates the market, right? Like you don't want to build something that's so esoteric that like no one gives a fuck. So I think it's not a bad thing that there's competition. I think it's a good signal. And my question is, to kind of gauge signal, have you either looked up SEO, like costs of buying certain keywords like posture app, or kind of what it would cost per click to buy keywords like that to promote on? Or have you created like a dummy lead gen page promoting the product as if it existed just to see if you get signups? Because these are I know my other entrepreneurial friends, these are tactics that they use to gauge kind of market sentiment and kind of get a feel for if there's a real interest in the product.
Yeah, that's a good suggestion. So I haven't done any of those things you just mentioned. So I'll write it down. I think it's definitely a good marketing step to understand the market better, for sure.
One observation that I have from this is just my feel. I am more comfortable wearing 1,000 accelerometers than I am having 1,000 pixels of image data taken of me, even though the information contained might be identical for whatever reason. And I don't know if that's, I'm just sharing a random thought that popped in my head.
Yeah, that's interesting, because I mean, it relates to the key question of consumer privacy, right? I think it's a big thing that's come up lately. You see all the blowback with Facebook stuff, with the proliferation of Signal and Telegram. And I think, I mean, that goes back to you, Don, of how you want to market this at some point, but potentially you can market this and say, we don't store any, or the only data, you can make a play there too, of like letting people know you don't do much with people's data.
Or so the tracking. Yeah. Like if you want to show progress, you have to track that data. And so you get the people that really want to like keep tabs on seeing a line go up, or see progress.
Well, the thing is that, so like both of the hardware options, both the Raspberry Pi and the iPhone, the idea is that the computation is done locally. So it doesn't require internet connection, cloud account, anything like that. So you keep your data on your local device. And so that I intend to keep doing that. I'm not going to make it a cloud product specifically because of the privacy concerns. Now you might say that, people might still not trust their own iPhone or a random computer that somebody shipped to them. I don't think I have a solution to that, unfortunately. It does require you to trust the devices that you physically own, for sure.
And then there's sensor fusion. Like, you could do accelerometers as like an add-on or down the road kind of thing, and just get even more accurate data, combining with your visual data.
Yeah, well, I mean, for sure. Just to be clear, the apps are not storing the photos long term because they don't need them. Just they analyze and delete the photo, keep the metadata, right? So there is for sure like the privacy aspect of that as well.
If you didn't show the data, but just showed a wireframe of me, I am totally comfortable with that. For whatever reason, that feels like, oh, that's, you don't actually have what I look like or anything. Even if you have like show me the depth map even or whatever, like
that's a good idea.
that feels
actually.
okay, you know?
Yeah, to show it as like a 3D model as opposed to actual photo. Yeah, I understand what you mean.
Puts my mind at ease, like, I don't know, all the
Yeah.
snooping kind of stuff.
Yeah, you know, it's a lot more psychological problem than like engineering or anything like that, right? Because it's more about presentation than, because I already made the app as private as possible. It doesn't send data anywhere. It keeps it locally. So everything else is more like psychology on top of that. All right, let's move on because I need to get to the demo actually. So the thing is that, so to make this posture analysis possible, I had to get a lot more fine-grained information about the person in the photo. And here's where I had to use this data set in the model in the project called DensePose. So DensePose is an open source project, which I'm relying on some of my computations. And so it does a lot of things. And one of the things it does, which is very useful for this particular project, is it performs segmentation of the body parts at the pixel level. And what that means is that, for example, here I highlighted it segmented, it found exactly where the pixels where my back is. And it's useful because now I can look at the outline of my back here on the right to understand what is the curvature of my back in particular. But how did I get there from here to understanding the posture? That's where the next few slides are all about. So basically the first thing I did was I kind of took this outline of my back and then tried to essentially convert it into like this a line that I have to analyze. So I take the coordinates of the pixels and I convert them by using a curve fitting function to just basically get a curve that I have described mathematically. And then it's useful because then I can talk about all different properties of this curve in terms of mathematics. So I do this for one frame. Okay, so we get this nice line of the back curve. How do we get from here to like a quality metric? So the big idea here is basically to have some kind of a reference frame. So here at the top, I have my supposedly very good posture, and then I convert that to a curve. And then I also have this other photo here which I'm trying to evaluate. I convert that also to a curve and look at the difference between the two curves. And the idea is that the larger the difference, the more I'm deviating from the perfect posture, and therefore it's a signal that the posture is not good. And of course, how big of a difference becomes too much is kind of like a threshold you can configure. You want this to be this sensitive or less sensitive or more sensitive. So, but basically the idea is that you have a reference frame. And it could be a reference frame of yourself or of somebody else. It kind of depends on body types and stuff like that. But that's kind of the backbones of the idea. Okay, so this is the first metric, is like the deviation of the curvature itself. So I did that and I realized that this is good, but not enough. I also needed a few more things, which are describing a few other things. And these are, so there are 3 more metrics I defined. And these are all kind of angle, deviations of angles in different body parts. So I defined, for example, here a metric for the angle between the spine and the horizon. And the spine here is defined as a line between my shoulder and my hip. And I take this line and compute the angle to the horizon. And the idea is that this line is supposed to be perpendicular to the horizon, right? It's supposed to be straight up. And so any deviation from a straight up is basically like an error, essentially. And so at some point, there's a threshold. If the deviation is too large, it's considered to be unhealthy. And then I defined 2 more angles. The second angle was the neck to spine. So this line here is between my ear and my shoulder is the neck line. And then I say that this line should be essentially parallel to the spine line. Or they should make basically one single straight line up. So like the whole axis is supposed to be aligned vertically. And of course, again, if there are deviations, I say that this is, at some point it's too much. And so we should consider alerting the user about that they're not sitting straight. And then finally, the last metric here was face to horizon. So I'm basically taking a line between the eye and the ear and saying this is supposed to be parallel to the horizon. And if it's not, then it's deviation. And so with these three metrics together and the fine-grained back curvature metric, I was able to put them together into what I think is very, very useful set of constraints. Like I tried using this for a few weeks now, and it like really keeps me upright and very well positioned. So let's see what we got here. Oh yeah, and then so we have these 5 metrics. So again, I still have the sitting or standing metric. And again, it's very important to stand up even if you're sitting perfectly occasionally. I have these 4 metrics for the curvature of the posture. And then another important ingredient here is observations over time. It's not just about how are you sitting right now, it's also about how have you been sitting for the last 3 hours and the last 3 days and the last 3 months. So I just want to make sure, to remind you that it's not just about the kind of real-time metrics, it's also about the long-term patterns. I think it's the demo time next. So any questions before I demo this?
I mean, I have some stuff, but I think I can hold off until after.
I noticed you said earlier that an idea was the backbone of the project, and it just clicked to me that was a clever line. You should totally pack your marketing website full of that type of stuff.
Yeah, fonts are coming. Okay, so all right, if no questions, I'll do demo. So I need to screen share from my second computer now. Demo, right? Yeah, it's demo time. I remember last time we did demo, I had issues for like 15 minutes. I don't remember if you remember that. Hopefully it will be better this time. Okay, seems to be still working.
You should also buy like black rimmed glasses and then find a filter that's the clear glasses that you're wearing for our next meetup to really do the the mind tricks on us.
Like how that GIF where like you take your shades off and you have second shades under that.
Yeah, just get double black rim, just keep taking them off.
Okay, let's start this. Hopefully nothing crashes. Okay, so what you're looking at is a live demo, but unfortunately there will probably be about 5 seconds of latency between what you see and my voice. So you have to account for that. And also right now the algorithm is not really optimized for speed. So it's also like processing, like it takes maybe like 2 seconds to process a single frame. Again, I'm not doing optimize this for speed yet. I obviously it will work in real time, when I get it to the more production stage. Okay, so what we're seeing here is essentially what you saw before. You have my back kind of segmented on the pixel level, and you have the lines which connect my eye, my ear, my shoulder, and my hip. And all of those things are kind of summarized using these metrics I have here on the right. So the first one, again, is sitting or standing. So I'm sitting, so it's red. I have the back curvature deviation. That's the deviation of my back curvature against the reference frame. The spine horizon angle, neck spine angle, and the face horizon angle. And then on the bottom, I have the plot of how my back curvature deviation changes over time. So we can kind of see how it changes over the last minute or so. So, okay, let me try to fix my posture right now so it's perfect. My neck needs to straighten up a bit. Okay, here we go. Okay, so right now I have my perfect straight and I'm doing as best as I can, basically. So here's my first attempt. Let's say I try to keep my axis vertical, but I will round my back a lot. See, I don't know if you can see, I'm rounding my back quite a bit, and immediately you can see the metric that measures the deviation is now red, meaning that it can tell that my back is too round. I've kind of relaxed my back muscles. Now they're not the way they're supposed to be. And if I straighten my back curve one more time again, now we're back in the green, and it's able to detect that. And of course, now I can do things like if I lean forward, which again, the idea is that it's not supposed to be sitting while leaning forward too much. I think the threshold is a bit, oh yeah, here we go. So you can see that I'm leaning forward because the angle between the spine and the horizon is now above the vertical threshold. And if I lean in the opposite direction, obviously the same is going to happen. So now also I'm now having a deviation, but in the opposite direction. And of course, everywhere in between, it can detect like all smaller things. Like if I'm, I can be both my back can be too round, and and also let's see, my neck to spine angle is also a bit too big. So it can detect basically all kinds of combinations of errors, so to speak, or offenses.
What does the work look like to optimize this so it does basically track everything at real time? What sort of stuff would you need to do?
It's pretty straightforward. Mostly, like, the thing is, like, most of the time right now, reason it's slow is because all these plots and charts are implemented in Python, and Python is notoriously not fast. So what I have to do is, like, basically, like, either not have to do plotting or find a faster plotting library, and that will be fine. Like, the processing itself of the video frame is fairly fast, and there are also like a tons of techniques to optimize things like neural nets and so on. So I was able, for example, like just for sitting and standing model, which is also pretty heavy model, it does neural net processing there, like XGBoost processing, just to understand sitting or standing. I was able to optimize it on the iPhone to be pretty much real time, like 30 frames per second. So I'm pretty optimistic I can optimize this as well to be real time on the iPhone.
And then also, I imagine the time series with the back curvature deviation. You also, I mean, if you wanted to, you can plot all of the different time series, right? Of like the spine horizon angle, the neck spine angle. Yeah,
for sure. This is just more of just one of the metrics. I just think that this back curvature deviation is one of the more interesting metrics because the other ones are kind of obvious. Yeah, angle and so on. And let me show you. So this is me sitting. Now, of course, like I have a standing desk. So the idea is that I want to do that as well. And so just to show you that it also works while I'm standing, here's me now standing. So now let me see, I can try to fix my posture. Oh, here we go. So see, I can now standing, and I'm also all green now. You can see that I'm standing, that all the angles are correct, that my back is on the right shape, and so on. So kind of the idea here is that it can work while sitting and also while standing. So yeah, it's pretty versatile in that way.
Is there a different baseline of correctness for standing? Like, is the spine supposed to be slightly differently curved when you're standing versus when you're sitting, or is it universal? It should always be the same shape regardless.
I don't know the answer to that question medically. I'm not a doctor, unfortunately. And by the way, I'm really looking for somebody with like medical experience in this area to kind of give me a lot more pointers, because I am guessing a lot of things here.
Yeah, for sure.
Like, I'm reading some articles online about some things. I found a bunch of actual medical papers around how do you measure different things about posture and about the spine, but I'm still very far from this area to be an expert or something. But yeah, so the medical part. And then in practice, I found that there are some differences in data that I get from when I'm sitting versus when I'm standing. But so far, I was able to use the reference frame of me sitting, and it was fine when I'm standing. So far, it seems that I can use the same reference frame for both sitting and standing.
Very cool. So also, by the way, by person, all those configurations of the back curvature deviation and the spine, like all those different components, I'm sure they have to be adjusted per person, right? You probably, because when you model them for yourself, it's like based on what you feel is a good posture. But I imagine we're generally similar, but there's some subtle differences to your point about having a professional look at this shit.
Yeah.
Where I probably don't have the same posture requirements that you have, for example. And then imagine, for example, if someone with like a hunchback, imagine if someone with some back issue was using this service where there's no fucking way that this thing would be like flashing red all day.
Yeah,
to use it, but those things can be worked around, but definitely important consideration.
Yeah, I think you're on the right track here, and I'm definitely, the way I'm doing this algorithm is that it is configurable in all the ways, meaning that it can be adjusted for a particular expectation of how you're supposed to be sitting. So both the curvature of the back you can pick your own reference frame. You can upload a photo to pick that as the target for your posture, for your curvature, right? So that's adjustable. So the idea is that the user can do that, for example. And also you can adjust sensitivities of the angles. Maybe you want the angle to be, a bit less sensitive, or maybe you actually need a different, for some reason, you need a different target for the angle. Maybe you want to have 10% angle between your spine and the horizon or something. So all of these things are totally adjustable. I think what's for sure will be kind of one of the next steps here is to understand in the kind of, as the user is, understand better kind of like the setup process for the user. And I'm sure we'll have to do a lot of that while doing the app to understand how to collect information about the user, how to adjust these parameters so that they meet the user's expectations. So for sure, there will be some kind of a setup process, and it will be, of course, also a challenge to make it kind of like easy enough for everybody to use. But so far, I didn't see any like giant red flags, like this will not scale to everybody or something. I think there's definitely will be some challenges, but I think it's possible.
It's interesting. I think about like at a macro level, and you can't collect the data for this, but if you could, it'd be interesting to see by culture, by race, all these other demographics. Is there a different average way of doing posture, or different average, I don't know, sitting up to standing down ratio every day? I don't know. Those are interesting questions.
Yeah.
Just about humans of the world. How different are we? Like, what's the variability of normal for this kind of thing?
Yeah. Those are good questions. I have no idea what the answers are, but.
Oh, hey, hi Gorkem. Good to see you. Thanks for stopping by.
Yeah, sorry guys.
No,
I was a little
go
late. Meeting before this ran a little over. So, but here I am.
Yeah,
nice to see everyone again.
We're happy. Yeah, we're happy you stopped by, man.
You jumped at the right time. It's the best part of the presentation is the live demo.
Yeah, I'm like seeing a really interactive demo. So like, yeah.
Yeah. I guess one thing I'm curious about too. So when you were looking at competitors, Danilo, there's like, I imagine someone might be doing this already, and it's okay if someone's doing it. It doesn't mean that you shouldn't. If anything, again, it validates. But you didn't see a service that is doing something similar to this, because I almost wonder if even like in the Apple Health app or some shit, if there's literally a feature that's like, leave your iPhone watching you at the desk, and we'll send sound notifications if your posture looks fucked up.
And like to add to that question, like probably like people are concerned with privacy, and that's why they don't want to film themselves all day, maybe. Like
Yeah, we already had a question about the privacy aspect. Like, just the TLDR is that the idea here is that it does computation locally, so there is no need to do internet connection or cloud account or anything like that. So as long as you trust your own hardware to run the software, which can be audited to be correct, as long as you trust that, then you can trust that this doesn't go anywhere. But I understand that this is a pretty big trust, especially for non-engineers, to understand what is the attack surface, how secure is this. You can put a label, it doesn't go on the app doesn't send data to the internet, but verifying that is pretty challenging for sure.
Yeah, and just from like a development standpoint, I mean, there's a lot you can do with like UUIDs to basically, for people internally, if you were to ever make this a whole company and you brought people in, you can mask PII identities with UUIDs and basically just kind of track users in that method. So it's not like anyone at the company can just see, oh, what's Gorkim's posture look like today? Or, well, how's John doing over the last week? So shit like that.
Speaking of competition, the one app I found on the ICE App Store that is concerning posture was an app that is supposedly sold to the doctors who do posture treatment in their office. Like, it's a doctor having an actual practice, health practice, they treat posture issues. So the app was basically like, again, it's the app that the doctor is using with their patients. But the thing is that within the app, there was absolutely no image analysis done. So the idea is that the doctor uploads the image and then manually says where are the different parts of the body, and then the app computes angles or whatever. But so it was kind of like half automated because it still required the manual process. So it's like 5 minutes to process one frame or something while you manually label it. So obviously it's not something that can go to the consumer who doesn't know how to figure out if their posture is good or not. But this app here is it's consumer oriented in the sense that you can give this to a user and they'll be able to, use the app without like a doctor or something.
And for competition, another opportunity could be sports related. So I'm thinking like golf swings or weightlifting. And those are two categories where people love to record themselves. Because like if you're a bodybuilder, you spend half your gym session looking at your muscles in the mirror, right? So they're not going to have that same concern about not wanting to show their body. But when you're like doing like a deadlift or something, like you want to know your back is straight when you're lifting the deadlift. And you might need a little more higher frame rate, I guess, for those quicker motions.
One thing this reminded me of is bike fitting. Like, so I did like a professional bike fit like a year ago, and like how far you are from the saddle and all that matters a lot. And like the really expensive ones, I think have like software like this that would measure like how much you are bending your knees, like your back, your elbows, the positions of that. I think like that reminded me of when John said like sports related. I think like bike fitting is like very, very relevant to this.
Yeah, I think there's quite a few sports where but weightlifting and others where kind of proper motion or stance is important. I was kind of debating for now, for as long as this project was around, whether they should go more into the sports direction, because obviously there's a lot of opportunity there. The one thing though is that, I don't know, for me, I feel like this kind of area is a little bit less crowded, I guess. So there's like 1 million people on the internet kind of trying to build a fitness app using computer vision, I feel like. And this is, so it's like an underserved area where I feel like there's an opportunity to make some impact. And there's also something that like almost, everybody who is like remote worker these days will need, right? As opposed to people who just do weightlifting or something. But yeah, there is maybe like as the company is growing or the product is growing, there will be opportunity to like enter this side markets, which are like near market, like sports and fitness and stuff like that. So I'm really trying to focus on like the office worker here right now.
You've got the foundation for sure. So avenues to expand.
My question to you too is like, in terms of you shared a slide of your roadmap earlier. It was kind of broad. In terms of kind of like immediate next steps, I mean, are you going to start working on the optimizing? Are you thinking about trying to gauge the product market interest with kind of some of the hacks we talked about? Are you trying to raise money? Like, what do you kind of what's immediate for you with this stuff?
Yeah, let me. I have a slide about that. So let me jump back to the slides now.
And yeah, whenever you do like the Series A or seed round and you're getting these fancy VCs in the mix, don't forget a small folk.
Yeah, wait, what happened to? Oh yeah, there we go. Okay, so there are some limitations of this current prototype, and I'll be very straightforward about them. The first one is that it relies on the camera to be at the 90-degree angle to the person. And that's because I'm using like this like side view to see your angle of your back, your posture outline, all those things that don't make sense if you're putting the camera straight forward towards the person, of course. And I also noticed that if you want the thresholds to be very tight, so you want the product to be very sensitive to small deviations, you really have to nail the 90-degree angle, because like if you have like 80-degree angle of the camera to the person, you have to then lower the threshold so they are less sensitive to deviations, because there'll be just natural deviations due to the improperly placed camera. So the solutions that I think about that is basically have to start looking deeper into 3D perception. Right now, basically all the analysis is kind of dealing with the 2D plane of the person. So there are some neural nets that can do 3D perception from normal cameras. There are also special hardware like LiDAR or dual cameras to perceive depth better, understand where the angles are. actual infrared depth cameras. So actually, by the way, both LiDAR and infrared depth cameras are now on the iPhone. So those aren't even that crazy of an idea to use this hardware as an option. So that's kind of where I'm next, where I'm trying to figure out how far can I push this product to depart from this idea that you have to be strict with 90 degree to the person, because it's not a super inconvenient thing to do. Like you just have to put the camera 90 degrees. It's a simple task, but it's something that maybe will be inconvenient in some situations where you have little space or other people around you, other tables around you, stuff like that.
So as you're like sitting and you kind of rotate your chair a little bit, as long as your average rotation, it kind of fuzzes out, I guess. Like if I sit slightly with my chair angled a little bit, rest my elbow here, that would break the 90 degree angle, I guess.
Yeah, it will for sure. And so whether it's a problem or not, it again depends on the sensitivity that you selected. If you selected that the thresholds are very tight, super sensitive, it might start getting false positives. If you kind of relax the thresholds a bit, it will be fine. So it kind of depends on what your goal is.
I do also think, just a quick comment, like looking over some of these things, like if you're trying to identify when you have some type of minimal product to test out in the market and get some signal. I mean, what do I know? I'm just one user, but I imagine if you do some of that optimization work to like make the camera and stuff go a little more real time, like you have enough basically to at least start, like, I don't even know if it's beta, it's like pre-beta testing, just like sharing it with people, get people to just try it. Maybe, I don't know how you can give people the opportunity to try it without it being on the app store. Like maybe it's something where like the images are stored locally, but you have stuff running on the web to operate it. Cause yeah, like I just see that, if you just you're telling people, hey, look, this is meant to be if you're working from home and you're just sitting at your desk and it's not very obstructed and you're using an iPhone, that's already a lot of people, I imagine. And comment.
I think the iPhone app is the obvious next step. I don't think it will be a big problem to copy this algorithm to the iPhone. Maybe it will take a month. I have on the next slide kind of my timeline for the future. But so yeah, I don't think like all these limitations are like super big in terms of like they're prohibiting the product from going to market. More of like what the current limitations of the algorithm is right now, which will have to be addressed in the short term. It also requires like, unobstructed view, which you can make possible at home. It might be a bit harder if you're in a public area like the office or library. And again, I think obviously like you working at home is a very, very direct target audience for sure. But I also would like to try to make it work in more public areas, such as the office, where people might be okay with you putting a camera on your tripod, or a cafe or something. But, that's a bit of like a visual thinking more than kind of, I feel like a proper current reality.
How does it handle armrests? Because I noticed your chair doesn't have armrests.
It's a good question. I have them off because of just for convenience, but I should put them in test that. I think it works fine when I abstract myself with my own arm. So it should be fine, I think, with the armrest, but I'll test it.
There's also a thing, if you're going to do this in cafes, maybe this becomes a dating app of sorts where, it forces you to go to the cute girl on the table next to you and be like, hey, do you mind holding my iPhone for a bit?
But, people who are like, working from cafes for like a few hours a day, that might be an option for them as well. If you have a wide enough lens so they can put the camera right next to them, then they can see, the whole body and so on. Okay, so the lens distortions, the one that John asked about, so the fisheye effect. Now, let me maybe get back. I don't know the other direction here. I don't know, so depending on how much experience you have with cameras, you might or might not see lens distortion on this photo. I do see it because I just deal with lenses all the time. I see my head is a bit stretched. My legs are stretched because it's a wide angle lens. It does stretching in some areas. And this is actually a problem for angle deviation problem, because obviously if you stretch the photo in nonlinear ways, your angles will be messed up a bit. So it's a real problem. And in photography, usually the way they solve this problem is that they have software correction, which is aware of how exactly the lens distorts the picture, so it can undo the distortion. It's possible. People do it all the time. It's just it's not very straightforward to do like a one-liner or something. But it should be possible to do some kind of calibration at some point. For sure, if you use a well-known lens like an iPhone lens or Raspberry Pi lens, we can find the distortion profile, undo that thing. But it's definitely a consideration for measuring angles. And so just like basically we're next for the app, like essentially, again, I want to launch the iOS version of the app with the posture, because right now it doesn't have the posture, just the sitting and standing. I think it's something like a month to 2 months away from being available. So definitely, we'll be looking for early enthusiasts who would like to improve their posture. And I'm also planning this year to raise a seed round. At least that's my goal for this year for sure. I feel like now this product is, there where there's a market, there is an MVP, or at least a prototype. There's a clear path to making an actual usable product which can be sold. So I think it's the right time. I'm also trying to figure out the marketing story a bit better. Like I've been focusing on the product a lot here, like thinking about how to use it, how to implement it. I haven't thought a lot at all about how to find, the customer base and address them in a very cost-effective way. So I'm definitely looking to find, kind of co-founder / CMO person who is interested in those type of problems. So yeah, so that's basically it for where I think this project is going next. So yeah, here's a giant thank you for your attention.
Let's give a round of applause.
Thank you.
Here, I'm also stop recording. And